Good day, guys. We are welcome to TPATHS Learning Center. And today we'll be looking at a new topic, air. Air, A-I-R, air. Is an important topic in term chemistry. And we'll try to make life very easy. We discovered that trying to take the whole concept would not be easy. So we decided to just work it focused on your jam questions. All questions you are seeing there, they are based on jam questions. And back-to-back years, air is a good question. It's a good part in chemistry that always come up. And we need to know what is air. Air is a mixture of gases. Mixture of gases. We believe that gas mixture is what is in air. And we need to recall that air comprises of nitrogen, oxygen, carbon dioxide, and the rare gas. Now we'll take the questions one by one. Now, the first question we have there, that is number one. Number one there is when air, which contains oxygen, nitrogen, carbon dioxide, water, and the rare gases, is passed through alkaline pyrogalon and then over quicklime. The only gases left are that. Now, many students do feel this question very, very well. What are they doing there? They're passing what? Oxygen, passing water, passing different things. What is the aim of doing that? The aim of doing that is to what? To remove one oxygen. The reason why I'm doing that, number one, I'm looking at the question there, to remove what? Oxygen. The next thing to remove is what? To remove water and also to remove carbon dioxide. So when you are using pyrogalol, it will remove three important things there. To remove three important things: O2, CO2, and water vapor. Sorry, O2, CO2, and H2O. Therefore, in gases, what will be left from the option there? What will be left when you remove all these things are N2, carbon dioxide, and what? Rare gases. Carbon dioxide and rare gases. So, sorry, I'm not removing O2. I'm not removing CO2. Now I'm trying to confirm. So N2, CO2, and what? Rare gases. If you want to test for CH2, CO2, you can use what? Lime water. So CO2 can be removed using what? Lime water. So how do you know that CO2 is present? Is that it turns lime water milky. Number two question, they said a gas jar was inverted over burning yellow phosphorus. Floating over water in a beaker. After burning, the water level was found to rise in the gas jar. The water level was found to rise in the gas jar. The water level rises because why is the water level rising? If you just go to the question, they are asked why is the water level rising? The water level is rising why? Because in that phosphorus that is burning, it requires oxygen. It requires what? Oxygen for it to burn. And in that case, they are using what? Phosphorus, P4, plus oxygen gas will give us P4O10. So this is the gas that occurs due to the combustion of phosphorus. When phosphorus combusts, we get P4O10. Very, very important thing we need to know. So the answer to that question is C. All the gas that has been used up by the burning. C. The next question: when a piece of charcoal enclosed in a cylinder containing air is ignited, what happens? you have charcoal. Charcoal can be said to be an hydrocarbon. Can be said to be what? An hydrocarbon. Is when a piece of charcoal explodes that is containing air is ignited. So you are trying to ignite charcoal and hydrocarbon. What happens? Yes, charcoal will burn. It will burn. And when it burns, what happens is going to increase the amount of the combustion of O2, of the hydrocarbon. And one combustion of that is what? The amount of CO2 is what? Is increased. Is increased. Is increased. Is that clear? Let's pause, please. I want to quickly check something. Breaking transmission. Um, in number three, we learned something. We consider the fact that in that enclosed cylinder, something like this, that is closed here, we believe that fine, there is charcoal in it. And as the question implies, the question is telling us that air is ignited. Air is ignited. And what happens because of the fact that air is ignited? What happens is the fact that the charcoals we keep on what burning. And we need to know that no matter any hydrocarbon we have, if you are burning it, you must get what? CO2. So since you are burning it, you are putting CO2. So what happens is the fact that the amount of CO2 will keep on increasing. As the hydrocarbon keeps on burning, the amount of CO2 will keep on increasing. And let's recall that we have CO2 plus what? H2O. CO2 plus H2O. So any of the amount there, it will keep on increasing in that cylinder. But in this question here, you can observe that none of the options there contains H2O, but we have CO2. And that is option D. The next question again, similar to what we talked about for the first one, we are considering a diagram. In the diagram there, we can see clearly air is passing through an opening. And we can see that in the beaker there, the beaker contains alkaline pyrogalol. And alkaline pyrogalol does one thing there. It removes, or better still, it extracts O2 or any presence of oxygen in the air. So O2 and what? H2O. Now, Rana asked a very good question. In the above experiment, X is what is X there? X is an outgoing gas. We don't know it, but in the diagram, the X is showing the arrow that it is going out of that experimental setup. And what happens? What can we say is the fact that O2 that the pyrogalol will extract any compound of oxygen or oxygen gas itself. Then what will be left from you can look at the options there. Option D, a mixture of oxygen and inert gas. Oxygen is there. No, because pyrogalol will remove the oxygen. The next option there, a mixture of nitrogen and carbon dioxide. Any carbon oxygen, apart from oxygen is present there, it will be what? It will be removed. So the best option there is a mixture of nitrogen and inert gases. Because that inert gas, they do not contain oxygen. So they will be what? They will leave the experimental setup there. And what you have left, what you have in the setup there is what? Oxygen or water or any carbon, any compound containing oxygen. Now, the next question we have, that is number 5. We ask the question here, for iron to rust, there should be present of for iron to rust. If this is electrolysis, so I said for iron to rust, we need what? Moisture. We need moisture. We need moisture. So for iron to rust, we need moisture. And what do we have here? We have seen oxygen, B, moisture, C, carbon dioxide, D, oxygen and moisture, oxygen, moisture, and carbon dioxide. We know CO2 is not there. So the answer is what? Oxygen and moisture. So moisture can be there, or oxygen can be what? Present for what? For a substance to rust. The next question there is number 7. We have been seeing what we've done before over and over again. So that should act as a revision. And tell us that question comes out very, very well. So the next question is number 7. I can choose to ignore it, but let's still take it again. Which NS passed through alkaline pyrogalol and then over quicklime, the only gases left are what? So when you pass it through pyrogalol, we know that we remove what? Oxygen and water vapor. So you are not moving through quicklime. Now quicklime we take what? CO2. Quicklime we take CO2. The quicklime we take CO2. What do we have left in gas is nitrogen and the rare gases. Nitrogen and the rare gases. Nitrogen and the rare gases. The next question then, in what respect will 2 dry samples of nitrogen gas differ from each other if sample 1 is prepared by completely removing CO2 and O2 from air, and sample 2 is prepared by passing purified nitrogen 1 oxide over heated copper? Sample 1 is dash. Now, this is a question that this is the application of the knowledge you know about gases. And this is a very good question. You can see the question there. We look at sample 1, we look at sample 2. Let's quickly show what I'm trying to say. Sample 1 and sample 2. Sample 1 and sample 2. Sample 1 and sample 2. So you can see sample 1 from the question there. Sample 1 is prepared by completely removing. So CO2 plus O2 are being removed from. So you remove this from we know that remove from, and this is sample 2, sample 1. Sorry, this is sample 1, and this is what? Sample 2. So sample 2 is prepared by passing purified nitrogen oxide. Nitrogen oxide. You are passing purified nitrogen oxide over heated copper. Over heated what? Copper. To get what? N2. Now we want to know. We are seeing purer, we are seeing denser. From what we have here now, if you remove CO2 and O2 from air, based on that question there, what do we have to say? Because if you remove CO2 and O2 from air, we are going to be left with something. In a mixture of gas, it contains CO2, O2, N2, and other rare gases. Now, sample 1, if O2 and CO2 is removed from air, then we know definitely that it's not only N2 that will be present there. So you're going to tell us N2. No, you need to know the fact that N2 plus rare gases. N2 plus rare gases. And we know that for this one, what we left is only N2. In that sense, we can simply say that sample 1 is denser. Why? Because it contains more than N2 gas. It is what? Denser. It is denser than what? It is denser than this. But the fact remains that in this air, it contains not only N2 plus rare gases. So the purity will be very, very purity is low, is low, is low. Purity is low. Now, because purity is very, very low, we need to note that this sample 1 will be denser and less pure. Let's look at the option. Which question, which options work with that? We can see that it is option B. Option B. It is slightly denser than sample 2. If you carry this, you pass it through copper, you are going to be left with what? N2. Both can leave out of the reaction medium. So the answer is what? B. B. The next question there, the approximate volume of air containing 10 cm cube of oxygen is dash. The approximate volume of air containing 10 cm cube of oxygen is dash. We are told that 10%. So the air contains 10%. 10%. The air contains 10%. So in that case, we need to now know something, that normally in air, 100% of air, normally of air is equals to 100% of air is equals to 20% of oxygen. Abi, your normal air, 100% of air is equal to 20% of oxygen. Therefore, how many percent? Therefore, how many percent? We don't know the amount of air, Abi, but we need to know that it will be, what is about 20% of air? So what should that be the volume of air? I don't know. X% is equals to 10% of O2. So let's cause and multiply. S will be equals to 10 times 100. 10 times 100 over 20. The answer is 50 cm cube. 50 cm cube. Please, you see it, we are applying it. And that's why you need to understand some things. Fine, you don't forget that you know that we are being told that in air we have about 20% of oxygen gas in air. So in that case, we need to know something very, very important, that in air we can easily do a relationship. Since 100% of air contains 20% of oxygen, therefore how many with 10% of oxygen gas give you in the air? So please, these are good questions, and every year it comes out. Please, let's not joke with this question. The next question we have there, we are told 10. Very popularly asked question. 10. In the exhaust fumes from a garage in a place that uses petrol of high sulfur content are bound to contain. Good question. My people, when you have fuel that contains high amount of SO2, that contains high amount of SO2, when burned in air, what happens? We know normally a complete combustion of fuel will give us CO2, H2O. Good. Incomplete combustion, in case it's not combusting very well, it's going to give us CO and H2O. But it now contains a high amount of sulfur content. Which sulfur will combust to give us what? CSO2. Let's look at the option and see which of them has that option. CO, SOX, SO3. CO and SO2. You see how they're tempting us. CO, SOX, SO2. Now, this is an high amount of sulfur. We know sulfur can combust to give us SO2. We also need to know that sulfur can also combust to give us various amounts of the gases. So we can say SOX because various amounts. Then look at the option there. CO, SOX, and SO3. It can be SO3 too. So CO and H2S, H2S can never be formed. No, it's not H2S. CO and SO3, CO and SO2. I think the best answer. The reason I'm writing SOS is because it is an high amount of sulfur. And we believe that more, you see, I wrote SO2 and SO3. And in the option there, they have SO3 only. SO2 can also be formed too. So this SOS gives rise to this SOS answers the question that it can be other sulfur compound. It can be other sulfur compound. And that is what happens in this type of question. Now, the next thing we need to consider there, number 12. Corrosion is exhibited by dash. Corrosion is exhibited by, where can we see corrosion? I did it earlier on. You can see corrosion in metals. They are seen in metals, all metals. All metals. You see all metals. Metals shown to have several funny options. Funny options. All metals, the answer, I don't mind their English. All metals are meant to what? They are meant to corrode. It now depends on the amount, on the way they corrode. Some will corrode faster, some will corrode what? Slower. I hope you get. Some will take time to corrode too. So all metals undergo corrosion. 13. In the above setup, substance X and Y are respectively dash. You say substance X removes CO2. Substance Y removes O2. Substance Z is a drying agent. Today, can we recall what you said today? Can we recall what you said? What is used to remove CO2 or to remove O2 rather? It is what? Pyrogalon. When you look at the option, sometimes we used to always think. If I don't know the answer, we'll look at the options. So we know that that means we assume that Y is pyrogalol. When you look at the option, I and copper, no. And concentrate, no. B and C is the only answer that makes sense. B and C is the only answer that makes sense. Is the only answer that makes sense. But we now ask ourselves a good question. We now ask ourselves a very good question. Lime water is what that can remove that CO2. And what is lime water then? It can be used as what? As KOH. KOH. The next question, the pollutants that are likely to be present in an industrial environment. In an industrial environment. Now we live in an environment where there is a low lot of okay. We've done 15. I jumped. We've done 15 before, similar to what we've done before. 16. The pollutants are likely to be present now. Many of us live in an industrial environment where we consider the fact that a lot of industries are using various chemicals, and they all act as pollutants. Fine, I've told you before, I've introduced the fact that air is a mixture of gases. But let's not forget that air can also act as a pollutant. And it's one of the problems we are facing now in this country. One of the reasons why we can easily see that the whole environment is extremely hot because of the air pollutants that disrupt the atmosphere. And that is the reason why you observe that a lot of people start getting various ailments because the fact that the air at which they take in has been polluted. And that's why you see various issues, various problems that happens to people living in such industrial environments. Some of them even have problems in their DNA. Even when they give birth to children have problems with their DNA and various issues due to air pollutants. And it's a plea to everybody that they should please look for various ways. You see people around that want to easily let them burn this, Don't allow things like this. And let us also cultivate good habits of taking care of our what? Of our beings, of our death. Is very, very important. It's very, very important. A clean environment is an healthy environment. And that's why pollution like this is an important what? Topic. And that's why is it an important topic? Why? Because we want to educate people. Let people just know that now you see how do you feel? You go in, you be in your room, everywhere is very, very hot. Or even under your AC, you are still sweating. Why? Because of what? Because of the air pollution. One way or the other, you might feel that it is not affecting you, but it is affecting you one way or the other. That's why you see a lot of people walking up and down using various things on their skin, using powder, using this, using that. Why? Because of what? The air pollution. So that's why. So you know, you're not asked now, what are those that causes it in the industrial environment? And you can look at the options there. Many of them, SO2 is an example, H2 is an example, oxide of nitrogen is an example. Um, for option C, NH2 is not, NH2 is not, ammonia is not there. So the answer to this question is what? Is option A. Option A. Number 17. Which of the following gases dissolves in water vapor to produce acid rain during rainfall? Very important question. So the answer, what dissolves in water to form acid rain, very, very popular, is what? SO2. So SO2 plus water, SO2 plus H2O will give us H2SO4.